Hello, I'm Jesco. You're watching Game Dev Made Easy, and in today's video, we're going to discuss the steps for conceptualizing your game development projects. Before we get into the video topic, however, I want to first say that there are many more comparisons and how it's developed episodes in the works. I have been extremely busy working on my AR programming with Unity book for PackedPub. Speaking of PackedPub, PackedPub is a fantastic website for finding books and videos on many different topics within the field of IT. They have books and videos on Android, Angular, Arduino, artificial intelligence, AWS, data analysis, DevOps, Docker, FinTech, Java, JavaScript, Linux, machine learning, Node.js, PHP, Python, R, Raspberry Pi, Spring, Unity, virtual reality, augmented reality, Vue.js, C#, C++, Unreal Engine, Colton, Go, TypeScript, and so much more. They currently have a massive skill-up sale going on where every book and video course is only $10. I highly recommend and utilize this site extensively. Before building any game, your go-to first step should always be to know or find exactly what you want to build. You don't have to know the exact implementation details, just what you want to build and how you want to go about building it. This should include things such as the basic idea or concept, programming language to use, game engine or libraries and frameworks to use, the platform to release on, the design document or design outline, and your proof of concept. Now, why are these points so important? They are important because it helps solidify the idea, gives a clear path for what you want to accomplish, and most importantly, proves that the project is possible to build. Let's dive into each of these points and go into depth on why they are so important on their own and the bigger picture. The basic idea, which is also known as the initial concept, is essentially your elevator pitch. That is to say that it is a short description of the idea that explains the concept in a way that the listener can understand within a short amount of time. The short description should be at most a paragraph in length, or 4 sentences that explain the entirety of the game's core mechanics. To give an example, the game I'm currently playing is SG/ZH, Schoolgirl Zombie Hunter. And let's go over an elevator pitch of this game's initial concept. Game concept is as followed. Shooting action game where there exist several firearms in the game such as handguns, assault rifles, sniper rifles, shotguns, submachine guns, and rocket launchers. Hide and attack the crowds of invading zombies, and at the very end survive and escape the deadly high school. Pretty simple and straight to the point. It doesn't go into the finer details like being able to change weapons and clothes in the character's menu. It doesn't talk about the music or art style, or even talk about the fact that there are rare item and clothing drops that you can select in the character menu. This is what a game concept or elevator pitch is. It is designed to draw in the person without too much detail into the finer points. Picking the right programming language. When developing a game, the choice of programming language is a forever present conundrum. That is because this should be answered in conjunction with what libraries, frameworks, and game engines you want to use, and what platform do you want to release on, along with why. With these 3 sections, you should be able to ask the question words and answer them. Who, what, when, where, why, and how for every aspect of these sections. Let's go over a few examples of questions you should be asking yourself. Who will be developing the game? What is the benefit of using X, Y, and Z? Where would X, Y, and Z cause problems? Why would X, Y, and Z cause problems? How would using X, Y, and Z solve the problems? Doesn't sound too bad, right? Well, let's use more real-world examples of the questions this time that aren't so vaguely asked. Who are the main programmers? Who are the artists? Who are the level designers? Who is not proficient in X programming language? What programming languages does the team or I know? What platforms do I want to support? What are the pros and cons of my programming language of choice? What libraries, frameworks, game engines are available for me to use with my programming language of choice? Where are the docs for the game engine, framework, libraries that I want to use located? Where would the performance bottlenecks possibly lie? Where would issues occur? Where could I find support for the language, game engine, library, framework that I want to use? Why would X language be better over Y language? Why would X framework, library, game engine be better than Y? Why would issues occur with my language, library, framework, game engine? Why should I choose these over the others? How would my programming language of choice solve possible problems? How would X framework, library, game engine better suit my project? How in-depth is the documentation on the framework, library, game engine of choice? How knowledgeable on my choices am I and my team with my choices? These sample questions showcase fully utilizing the question words in regards to choosing and utilizing a programming language for library, framework, platform, and game engine. These are the types of questions you should be asking all throughout the planning and execution stages of game development. The design document. For very small projects, a game design document shouldn't be necessary, but it doesn't matter. You should always create a game design document to outline the entire game idea with everything spelled out clearly and concisely. The reason for this is not only to keep up with what you want to do with your project, but to also make sure that not only can you go back and reference the document for what you need to implement, but to make it so that if you have a team, they can reference it and know exactly what the vision is for the game. The document should be written in such a way that you know exactly what the core elements of the game are and what are extra milestones that aren't needed for the main release of the game but would like to be added in the future. The proof of concept. The proof of concept can be a small level that incorporates the core mechanics of the game. This can be implemented in any game engine or language as long as it showcases the core mechanics of the game are there and implemented. Let's say you're going to use Unreal Engine to create your game. You could use GameMaker or Unity to do your prototyping to showcase the proof of concept. Alternatively, you can also use Unreal Engine. The main point is to have the concept solidified and something to show that what you want to create can be done by you or your team. It should be done as a separate project that can easily be scrapped, as you don't want to use beta code that isn't optimized or written sloppily, which the proof of concept will indeed be written in a sloppy and unoptimized manner. The project can and should be kept to test out other mechanics or implementation tests. And now for a bonus, UML. Prior to working on the proof of concept, it is a good idea to create a UML of the project so you know what methods, properties, interfaces, classes, and attributes you will need, as well as their relationship to one another. The UML helps to solidify everything you need to do code-wise, and the best part about it is that it is language agnostic, which means you can use it for any programming language, and that includes things like visual scripting like Blueprints with Unreal Engine or FlowGraph with CryEngine. Let's do one more bonus, repositories. Having a private repository where you have a main and working branches for your actual game is a huge boon and highly recommended. This allows for you to have your stable code kept separately from the experimental or code you or your team are working on, while at the same time not breaking any features currently present. To give a great example of this, let's say you are working on a modification to your code to add new mechanics for your door and you make a huge mistake which breaks everything and you can't remember how the original code looked. You have a separate branch that you can reference or pull to overwrite your broken code without losing it and having to start from scratch. Starting from scratch on something you have previously already made is extremely disheartening and causes a developer to not want to continue working on that project. That's it for today's episode, and I will have more videos up in the near future as I continue to finish the last few chapters of my book with the edits I need to make. I'll see you in the next video. I want to give a huge shout out to my Patreons who support my work. I will be working on your video, Loki, and it should be up within the next few days.